Welcome everyone to our session at Build Summit. Thank you for joining me. I'm Felipe Hoffa, Data Cloud Advocate for Snowflake. And today we're going to talk about Java UDFs in Snowflake in a session called Unleashing the Power of Java UDFs with Snowflake. So let's get started. Why do we have Java UDFs? What problems do we want to solve with them? Can I show you a demo of how they work? Yes, that's what this session is about. If you have any questions, feel free to ask them live in the chat that is happening in real time. Or if you have questions in the future, after the event is over and you're watching this video at any time at your convenience, if we're not live in the chat, you can still come to Stack Overflow. You can come to Reddit/r/Snowflake, or you can also find me on Twitter and LinkedIn. So let's get started. Java UDFs in Snowflake. The first thing people ask us is why have Java UDFs or JavaScript UDFs as we already had? That's because SQL is an awesome language. You can do a lot with SQL, even things you didn't think it was possible, but still, it has some limitations. And sometimes things are better solved with complete languages like JavaScript or Java. And Java has some really nice features that can complement the abilities that we already had with JavaScript. For example, if you have programmers working with Java, they can package this functionality in jar files, and then they can send it to your data engineers working on Snowflake, so they can use this functionality while everything stays in separate worlds. You have your Java world, they build the functionality, they package it in a jar, they send it to Snowflake so your data engineers can connect it to their Snowflake account, and then your data analyst, anyone writing SQL inside Snowflake, can leverage those functions. So, and then if you're running this Java code inside Snowflake with the rest of your code, then you don't need to manage a separate environment because it's all being run in the same warehouse. And this enables for a lot more use cases on data engineering, for data science, and we're going to see some examples of that. But before with this chart, what I want to show you is a little bit of how we see the Snowflake processing engine and how Snowpark is part of it. Snowpark is how we call this whole system and abilities for Snowflake to have your custom code run in Snowflake or outside the Snowflake, but we are extending the power of SQL to other languages. So data engineers, data scientists, software engineers can use their favorite language while letting Snowflake run this code and process it. And you can see in this chart that we have two layers of APIs, the client-side APIs and the server-side runtime. There are more ways to work with Snowflake. What you don't see here is also all of our API clients that we have for different languages. That's the typical way of just calling Snowflake from the outside. But then with the Snowpark, we added, for example, the ability to write Scala code outside of Snowflake. But with these Scala libraries, all of the processing of the data is happening inside the Snowflake. So you write Scala code, you work in your environment with data frames, etc. And the Snowpark libraries transform the Scala code transparently into SQL queries that are run inside the Snowflake, and then the whole processing happens way faster because the data is not moved outside the Snowflake and the processing is happening at Snowflake speed. And as you can see this chart, right now you can do that with Scala, and soon you will be able to do this also with Java, with Python, and other languages. But we have another layer here, the blue layer, where we instead of writing the code outside of Snowflake, we can do everything inside and run SQL, Java, JavaScript UDFs, or even call external functions where your code is executing inside the Snowflake. Most of the processing happens inside the Snowflake. And if it's an external function, then your SQL queries can call external systems. I've written about that in different places, but for today, we want to focus on Java. Something that gets a lot of people excited about this specific chart is that we are going to soon hopefully announce Python UDFs in Snowflake, and that will be really cool. But today, let's stay with Java. So let's talk a little bit about our Java functions, and I'll rehash what we've said so far. We can transform and augment your data using custom logic running right next to your data with no need to manage a separate service. You build the jar, you build the Java code with your favorite Java tools. You can deploy this jar to Snowflake, and once it's in Snowflake, you only have to bind it to a new function. You can use any third-party library. You can use this, for example, for machine learning inference and scoring. You can get all the benefits that we have been talking about. And if you want to go really deep into this, our documentation is awesome. Instead of just going step by step on the documentation here, I'm going to show you some of the highlights, and I'm going to demo how you can make these things work. Let's start with the simple example. I will show you this example live in a second. But before we get there, I want to prepare you and to show you our SQL syntax to create a very simple UDF. This is SQL code that you can run in Snowflake, and all that all that we're doing here is we're creating a function that adds two numbers. It takes two integers and it returns another integer. And here comes a special part about creating this UDF, is that we're saying that it's written in Java and we're giving it a handler. So basically we need a class with a static method that in this case is the class test with the add static method. If you see here, I have the code for that static method inside my SQL query. So I'm just saying I have a class test. It has this static method, and it returns x plus y. Really easy. You will see it working in a second. What if you have something way more complex? In this case, the Lingua project that I found on GitHub that allows you to detect the language in which any sentence, phrase has been written. Well, I took it out of GitHub, I compiled it with Gradle in my system, I created a jar, and then this is how I connected it to Snowflake. Again, it's the same syntax as before. It has a little bit more complexity because I'm taking a whole project in now. I'm creating the function. This function detects a language, it receives a string, returns a string. It's written in Java. And here is the fun part, imports. Once I get the Lingua jar inside the Snowflake, I just can call it out, find it here. This is the name, this is the jar. And then comes the handler, which is my custom code to connect both worlds. And you can see the handler here. I'm importing the library that I loaded. And all I'm saying here is I'm initializing it, the detector, and then creating this method that is detect. And we will see this working. But so we will see working here, and I'm going to demo you this live to show you that this is all real. Is for 4 different sentences. Languages are awesome. Hola mi amigo, hello friend, and je ne parle pas. You can see, and this is what we want, is we want to find out in which language they were written. So without further ado, let's go into the demo. And again, if you have any questions about this, we are here to answer them either live right now during our Build Summit, or you can find me on Stack Overflow, on Reddit, on Twitter, LinkedIn, so many other places. Let me load my Snowflake Snow site. Here I have my code ready for you. I'm sharing my screen. And this is what we just saw in the slides. Now I'm going to run it live. Create or replace this function that adds numbers. You can see it took only 2 seconds to create it. This Java code was compiled by Snowflake in real time, and now it exists inside Snowflake. And I can do simple things like add 2 numbers. 3 plus 4, it's 7. Wow, I didn't know this. Hopefully you like these results. But again, I have the statistics of how this ran. And you can see that we have created a function and we are able to modify it, change it. But at the end of the day, anyone that's writing SQL queries can use this function as if it was a native Snowflake function. For the more complex case, first I took Lingua and I compiled a jar with dependencies. I didn't need to do this, but it makes it so much easier if you have your whole package in one jar. So then with SnowSQL or your favorite tool to bring data into Snowflake, you put this file into Snowflake. I took my own jar. I sent it to my own internal stage. It's 148 megabytes of Java code and dependencies. And then I can just create or replace this function. Detect the language, it returns a string, language Java, and it has this little handler that, again, I can compile and use here. And of course, this compilation is going to take a little longer. Still, it's all handled inside the Snowflake. I'm not using any external process here. And now for the great part, let's call my function here. I have my 4 sentences and I want to detect the 4 languages. Languages are awesome. Hola, mi amigo. Hello, Freunde. Je ne parle pas. Yes, it works. English, Spanish, German, French. You might have noticed that I skipped some other examples here. Let me show you quickly what I did here just to play. On my first example, I'm just detecting 4 different languages. I could have used Lingua to detect all languages. It just takes a longer time to run. But with Lingua, you can optimize for using certain languages or detecting all languages. Both work. And then also I'm doing some experiments with optimization. So if I want to detect languages faster, sometimes you can get a benefit from sending multiple rows in one call to this UDF. So instead of sending a string, I can send an array and I can return an array. And basically I'm doing the same. I'm just processing these UDF, these strings in batches. And again, you can see how the speed changes because Snowflake gives you the statistics of where time is spent. And we can look in a second how much this changes depending on what you're doing. A couple more examples. Let's say what you have now is HTML inputs. You've been collecting web pages from around your system, from around the world, doesn't matter. You have HTML code and you want to process it. This could have been easy with JavaScript using DOM tools, but usually in any process where you have JavaScript UDFs, the DOM has been disabled because it's part of the browser experience. So if you cannot do this with JavaScript, which is the case now, that's okay. You can do it with Java. I have done it. I took Jsoup, a classic library for this. I'm taking Jsoup, and all I'm saying here is take the Jsoup jar. This is my glue code. My glue code is, in this case, to create a function that extracts the text. does Jsoup the parsing and returns the text. So for example, if I have HTML code like this and I only want to extract the text, perfect. It removed all of the HTML markup, it returned me the text. Or for example, if I have HTML code here and I want to extract all the links, all I need to do with Jsoup is parse it, look for all the links, run a little map extracting the links and returning an array of strings. And yes, you can see here that in this UDF, all the links were extracted. And there's a lot more fun that you can do. Let's see, for example, you want to know what JDK version Snowflake is running of Java. You just can get the system.get property and look for the Java version, and you can get some insights about that. And those are the examples I have today. Remember that also with Snowflake, you have access to see how all of these things run, where did the time go, how you can improve it. Let me go to compute. Here, I have my query history. Let's say, for example, Jsoup all links. Of course, I only processed one row, but you can see exactly where the time went. Total execution time, most time was spent during the initialization. We have the statistics of how much processing was done by the UDF, how much was done in SQL. You can use these statistics to optimize your code. Java functions, they make it possible to perform all kinds of computations using Java inside the Snowflake. You just saw me showing you how to run scalar functions. If you're looking forward to also writing your own table functions and store procedures, hopefully we will see that very soon. A little bit about the execution model, if you were wondering. As I was telling you, everything runs inside Snowflake. You are already defining what warehouse to use to process your SQL queries. The Java code runs inside the same warehouses because each of these nodes, they have their own JVM executing this code. And the nice part is that the JVM lifetime is only as long as the query is executing. So you don't have cross-contamination between different processes, and all of the optimization with the data, for example, those 140 megabytes of code that I have there to run my language detection. We are leveraging local SSDs that makes this whole processing really, really fast. And again, because it's running in Snowflake, always you get all of the benefits of our cloud services layer, which a really important one is security and keeping all of your data secure and well managed and well governed, which you get with Snowflake. Let's talk a little bit about using Java UDFs for machine learning. This is great because you can do your training, you can create your models, but once you have created a model, then the question is, where do you run it? How do you score your data? How do you test it? How do you evaluate it? Well, you can use Java UDFs for this. And this is part of the problem we want to solve. Like, if you can see here, the whole process of machine learning, first you need to collect data, visualize and understand it, do your feature engineering and transformation, and Snowflake is really great with all of that. Have all your data in Snowflake, understand it with Snowflake, do your feature engineering. Training, you can work with many different tools for training. You can work with awesome Snowflake partners. And then when you need to deploy these models, you can now bring it back to Snowflake, a jar file that will be run in Java. As we see here, according to Forrester, that's one of the biggest problems once the models are created. Struggling to operationalize or taking your proof of concept into production we are helping with that, and you can get that done with Java UDFs. You can get rid of your model serving environment, because now it's running inside Snowflake with the rest of your processes. And you don't need to spend more time transferring data outside of Snowflake. Forget about the cost of moving data, forget about the latency, forget about the security implications. And here we can see the traditional external serving model, where, of course, you prepare your data in Snowflake, you create the model with your favorite tools, and then when it's deployed, the model still exists outside of Snowflake, and Snowflake can call it, for example, with external function. But with a Java UDF, what you get out of your ML training and modeling is you get a jar file. Our partners support this method, and you get that jar file back into Snowflake, and then all of the deploy stage can happen inside the Snowflake for way better control and speed. And let me go to the next slide. Yes, some of our partners leveraging this model are DataRobot, DataQ, H2O AI, and we keep seeing more people do this. This is, for example, a blog post from June on how DataRobot does this. They have the exact code that you need to bring this jar, the jar that they built into Snowflake. So you can see that here that once you start working with DataRobot, you build your models, refine it, and when you want to bring it back for serving in Snowflake, they will provide the jar package, and to configure and execute it, so to install it in your Snowflake account. Once you have your database, your schema, your warehouse, you just need to bring this jar in, and you create this function that binds it. It imports the jar, it defines a handler that it's already defined inside the jar package, so you don't even need to write custom code. Same with H2O AI, and they have a session today with us at the Build Summit. So if you want to go deeper into this and see them doing this live, please watch that session. I love that we have so many awesome partners in the machine learning space leveraging the abilities that we're giving Snowflake customers. Let's take a quick look at best practices for when you're developing your own Java UDFs. First, think about how you're mapping the types between SQL and Java. You can find a lot of tips in our documentation. The big part is, for example, strings are really easy to move from one world for the other, but numbers, for example, you should be careful about how when you choose a big integer or a big decimal, or for example, floats versus doubles. In the Snowflake world, for decimals, we usually use a float. They are great, but if you have them as floats in Java, you will lose precision. Instead of using floats in Java, use a double, and that will map exactly to the float type in Snowflake. So just be careful with those transition points of what types you use in SQL and how they map back to Java and back. Also, for performance, think about doing one-time initializations. Instead of doing this initialization each time someone calls the UDF, use the static class that you are using for binding to do the initialization outside of the particular method. That will save a lot of time when people are running the same function for many rows. Logging support, you can do some basic debugging right now with write time exceptions, and you can get that back into SQL. But we're looking for better ways of doing logging. For now, just do the typical exceptions and try outputting the results. But again, if you're doing most of the development of Java code inside Snowflake, you should consider moving to a proper Java environment and just doing all of your test development there and importing to Snowflake the jars when they're ready for production. And of course, as I showed you during the demo, check your query statistics as you are optimizing, as you are seeing the behavior of your Java functions. Use the query statistics that Snowflake gives you to optimize the whole process. So key takeaways: execute Java functions inside SQL with no need to manage separate environments. That's really cool. You can build, share, and deploy custom logic with jar packages. And you can, with this, you can expand your use cases with Java as part of your ML pipelines, ML workflows, data pipelines. There's so much that you can do with this. To see my code to run these Java UDFs with my examples, just go to this Medium blog post that I wrote, and you can follow step by step. We have more resources at developers.snowflake.com. Complete the guides at quickstartsnowflake.com. And of course, find me on Reddit, find me on Twitter, find me on LinkedIn. Let's have fun together. Thank you very much. And hopefully I'll see you around. Thank you.